First of all, when you're done, this is going to go on page 18 of your notebook, so make sure that you attach it, okay? We're still dealing with polynomials, except now we're looking at area and perimeter. So who can tell me how to find the perimeter of any figure? Add the sides. Okay, so if you want to find the perimeter of anything really other than a circle, because that's circumference, you're going to add all the sides. How would you find the area of a square or a rectangle? What's the area of a square or a rectangle? Length times width. Only one person knew that? No? And just for fun, because you may need it, how do you find the area of a triangle? 1/2 the base times the height. That might be important to write down, especially if you don't remember it, because you probably will need it for your homework. Okay, so if I want the perimeter, it says perimeter and area of the figure. So let's start with perimeter. I have to add up all the sides. So this top side is 8 plus 3 plus 5 plus 6 plus 2. What's this side here? 6, because it matches. And what's this side here, this little piece? 1. How do you get 1?
Because the top is 3, and 5 plus 2 is 7, and now I need a little more.
Good. So the whole thing is 8. This piece is 5. This piece is 2 for 7, which means this piece has to be 1 to add up to 8. And then what's this? 3, right? Because it matches here. So if I add all of that together, 8, 11, 16, 22, 24, 34. Did you get 34? Okay. And for perimeter, who remembers what your units are? What would my units be? 34 what? Centimeters. And do I leave it just like that? Yes. Okay, so 34 centimeters is my perimeter. Now I also want to find the area of the figure. But this is not a shape, as of right now, of something we know. But as I walked around, some of you did some important things. What did you do? So if you can't find the area of that specific shape, Connor, what did you do?
I sectioned off each rectangle.
Okay, so did you draw on a line here maybe?
Yeah.
So now I have 2 rectangles. Do you know how to find the area of a rectangle? Yeah, we just said it's length times width. So 8 times 3, 8 times 3 gives you what? What? 24. So this area right here is 24 centimeters squared. What's this area going to be for this rectangle? 12 centimeters squared, which means the area of the entire thing is 36 centimeters squared. We add those together. So if it's a shape that you don't know, you can break it up and still figure it out. Okay. Any questions on that one? Number 2, find the area of the shaded region. So first of all, the shaded region is just this outside piece. So if I find the area of the whole thing, that gives me all of this. I don't want all of that. I just want the outside piece. But let's start there. Let's find the area of the whole rectangle. So the area of the large rectangle is 27 times 10.8. And what do you get when you multiply 27 and 10.8? 291.6 centimeters squared. Okay, so that's the area of all of this. I don't want this middle piece, so what do you think I need to do? Huh? Oh, it's inches. Thank you. If I don't want that middle piece, what do you think I need to do? Subtract what? The area of that middle section, right? So I'm going to find the area of the smaller rectangle, which is 9 times 19.8. And I end up with what? Hold on. Stand by. There we go. Okay, so the area of the smaller rectangle is 9 times 19.8, which is 178.2 inches squared. But I want this shaded region. So I have the whole rectangle, I have the small rectangle, but I just want this shaded region. What am I going to do with those two? Subtract them. I'm taking out, remember when we did composite figures for volume and we took out something that was inside of like a cylinder inside of another cylinder? We had to subtract the pieces. We're doing the same thing here. So 291.6 minus the 178.2 gives me 113.4 inches squared for my area. Okay. Any questions on those two? So what if we throw in a polynomial? Right here we have binomials for our side lengths. We don't just have numbers. I give you the formula for area of a trapezoid. So let's break down what this means. What do you think H stands for? Height. And do we know anything about heights? Like which one would be our height, do you think? X plus 1. So just as a reference, the height of a trapezoid creates a 90-degree angle with the base. Okay, so the 90-degree angle with the base is the height of the trapezoid. What do you think B1 and B2 stand for? Base 1 and base 2. So let's plug in these binomials and see if we can simplify. We're going to do it together, but let's plug it all in. So the area equals 1/2 of the height right, times, and it doesn't matter which one's base 1 or base 2, so I'm going to just say base 1 is the 4x plus 7, plus base 2, which is 6x minus 5. So 1/2 the height, which is x plus 1, plus both of the bases. You see how we plug that in? Can you simplify that, or can we simplify that? Where should we start? Before we distribute, where should we start? How about this set of parentheses? Because what can I do here? Combine like terms. Okay, so I'm going to rewrite 1/2 and then the x plus 1. And if I combine like terms, I get what? 10x plus 2. I think we can probably still simplify. What can I simplify now? What can I do here? So ignore that 1/2. What do you do with that? Distribute or box. So I'd like you to do that right now. Either distribute or use the box for x plus 1 times 10x plus 2. Okay, so we combine like terms, and now you're distributing using the box or distribution. Is that what you got? So when you distribute or use the box, did you get 10x squared plus 12x plus 2? Okay. Do you think there's one more step that we probably have to do? Distribute the 1/2 in. But if you look at all those numbers, what do you notice? They're all divisible by 2, so that fraction's going to go away and we don't have to deal with a fraction. But if I distribute in 1/2, the area of this trapezoid, so 10 divided by 2 is 5x squared. 12 divided by 2 is 6x, and 2 divided by 2 is 1. So if we were eventually given a value for x, we could find the actual area of the trapezoid. But here we just use polynomials to come up with a general formula. Okay, so we're taking what we already know because you're really good at multiplying, and we're applying it to something else. Okay, are we okay with that? Questions on that front part? Are you sure? Okay, so let's look at a farm. So, or a garden. This can be our garden. We're going to build this garden. And in order to build this garden, we have some dimensions. We're not given whole numbers, but we're given dimensions, and we're going to come up with different expressions. So, problem 4 says, write a simplified expression that represents the south side of the field. Okay, I even gave you a compass. So the south side of the field would be all of these pieces here. So if I want to write an expression that talks about the south side of the field, what do you think I'm going to do? So use the knowledge that you've learned over the last couple weeks to tell me what we think we're going to do. And crickets.
Here's the entire south side of the field. What would you do to get the entire south side?
I heard it. Add them all up. Okay, we want to know what the south side is, so we're going to add them all up. So 5x plus 2 plus x squared minus 9 plus x squared minus 7x plus 12. We're just adding up the south side of the field. But I hope you don't like the way that looks. No? So what would we do from there? Combine like terms. What's my highest exponent? 2. So 1x squared plus 1x squared is 2x squared. 5 minus 7 is a negative 2x. 2 minus 9, 2 minus 9, negative 7 plus 12, positive 5. Okay. This really is nothing different than what we've been doing. It's just in a context with a word problem. Okay, you know how to combine like terms. Does everyone see what we did? Okay, so number 5, write and simplify a polynomial expression that represents A, the perimeter, and B, the area of the pumpkin field. Okay, so all you are looking at is that piece there. So I want you to take a second and I want you to write an expression that represents the perimeter of the pumpkin field. And how do you find the perimeter of something? Add all the sides, and there are 4 sides to this field. So take a second and write an expression that represents the perimeter of the pumpkins. So if I want the perimeter of the pumpkin field, I'm going to add up all four sides. So let's start here with 5x minus 2, and then I'm going to add to it 5x plus 2, and then I'm going to add what?
5x plus 2, 5x.
Another 5x minus 2, and another 5x plus 2. Because if it's a square or a rectangle, the opposite sides are going to be the same. Now I can combine like terms. So my perimeter equals 5x plus 5x plus 5x plus 5x. 20x. Negative 2 plus 2. 0. Negative 2 plus 2. 0. So the perimeter is just 20x. How would I find the area of the pumpkin field? So you're going to multiply the length times the width of the pumpkin field, right? If that was a 5 and a 3, you would multiply 5 times 3. So you're going to do the same thing, except I have a 5x minus 2 and a 5x plus 2. And how do you multiply those two binomials? Distribution or the box. So I would like you to distribute or use the box. And you might notice that this is one of your special products from yesterday, which means you can technically use the trick that you probably caught on to. If not, distribute or use the box, that's fine too. I noticed that it's one of my special products. It's known as difference of squares, which I think you were given yesterday, which means I can use the trick and tell you that the answer is 25x squared minus 4. If you use distribution or box, you should have gotten the same answer. Did you? Yeah, that middle term cancels out? Okay. So number 6 is exactly the same, except you're looking at the potato field. So I want you to write an expression for the perimeter and the area of the potato field. So you do it with your group, but see if you can do the potato field. So number 6, if I want the perimeter of the potato field, we would have an x squared minus 7x plus 12 plus an x plus 6 plus x squared minus 7x plus 12 plus x plus 6. It's a lot. So x squared and x squared is a 2x squared. Negative 7 plus 1 is negative 6. Minus 7 is a negative 13. Plus 1 is a negative 12x. Are we okay so far? And then 12 plus 6 is 18. 12 plus 6 is 18, and 18 plus 18 is 36. So that should be your expression for perimeter. Did you get that when you combine like terms? Okay. If I want the area, I'm going to multiply the binomial times the trinomial. I'm just going to distribute. So let's see. X to the third minus 7x squared plus 12x. And then 6x squared minus 42x plus 72. So my area is x to the third minus x squared minus 30x plus 72. Did you get that when you multiplied? No? Yes? Did I do something wrong? Did anyone get that? Okay, well, a couple people did. Did you even do it on your own? Did you try to? So right now we're doing literally the same process over and over again. You are combining like terms and you are multiplying. I told you if you could do those three things, add, subtract, and multiply, for this next test, you're good. But you have to be able to apply that knowledge into a situation like this where it's not just, here's your problem, solve it. Okay? So if I'm looking at the squash field, this one's going to be a lot quicker. We're just going to go through it. So if I look at the squash field, look at your picture above because I know you can't see mine. We have a 4x, an x, a 4x, and an x for perimeter. 4 plus 1 is 5, plus 4 is 9, plus 1 is 10. So my perimeter should be 10x for the squash. So 4x plus 1x is 5x, plus 4 more is 9, plus 1 more is 10. Okay. And then area for that one's nice and easy, right? It's length times width, so x times 4x. And what's x times 4x? 4x squared. The beans might be a little tricky because we have xy. Do you see that for the beans? So let's do that one. Okay, so for perimeter, I'm going to start with the xy plus 1. Then what would I add to it? Xy minus 1, so plus xy minus 1. And then another xy plus 1 and another xy minus 1. What's considered a like term? Yes, so the xy. So same variable, same exponent. This xy is all a like term. And how many of them do I have? 1, 2, 3, 4, because the coefficient's a 1. So 4xy. 1 minus 1 is 0. 1 minus 1 is 0. So my perimeter is just 4xy. The area of the bean farm or field is the length times the width I'm going to use the box here because I think if you distributed, that's fine. But let's look at what happens with the box. So down the side, I'm going to put xy minus 1. And along the top, I'm going to put xy plus 1. What is xy times xy? Xy times xy. X squared, y squared. X times x is x squared. Y times y is y squared. Xy times 1 is just 1 xy. Xy times negative 1 is negative 1 xy. And negative 1 times 1 is negative 1. And we've talked about that your diagonals should be your like terms. Are they? Yeah. They're both xy's. Okay, so I'm going to start with my x squared, y squared. What happens with these like terms? They cancel out. Right? Negative 1xy plus 1xy is 0xy. And then I have this minus 1 at the end. Do you see how we're applying what we know? Yeah? Okay, last one. Write and simplify a polynomial expression that represents the area of the cornfield. Okay, well, what's wrong with our cornfield? We need to split it into two shapes so that we can actually figure it out. So what would be the easiest split, do you think?
Washington.
Right here, maybe? Because I know this piece here is x squared minus 9. Do I know what this side length is? X plus 6. It's the same as the potato. And I know this is 6x. Do I know what this length is? xy plus 1. So we need to find the area of each of these square rectangles and then add them together to find the whole area. Okay, so let's do this top part that says corn first. So we're going to do 6x times xy plus 1. You can't see me write that. Try again. So if you look up at the top, we're doing it where it says corn. So 6x times xy plus 1. What is 6x times xy? 6x squared y. And 6x times 1 is 6x. Okay, so that's that first part. Now that bottom square, what am I going to multiply? X squared minus 9 times x plus 6. And that you either use the box or distribute. Let's just distribute together. So x squared times x. I think I heard it. X to the third. X squared times 6. 6x squared. Negative 9 times x. Negative 9x. Negative 9 times 6. Negative 54. There is nothing like terms for those, so I can just rewrite it all in one line. Are we done? No, what do we need to do? We need to combine like terms. We need to add this answer to this answer. So because of this funky y, let's just, we'll throw that one in the front. So we'll do 6x squared y, and now let's go highest exponent from there. Where would it go next? X to the third, so I'm going to rewrite that one because there's only one. And then there's only one x squared, but I can combine the x's. 6x minus 9x? Negative 3x. And then that minus 54 at the end. Did we do anything that you didn't know how to do? No. You just have to be able to apply what you've learned to different situations. And in this case, we're talking about whatever garden or farm someone's building. Okay, questions?